wanted to do this next one, okay, which is root x, say at x equal to 3, we need to look at something that you've done before, but we need to refresh in your memory on it, which is called rationalizing the denominator. In this case, we're going to rationalize the denominator and the numerator so that we can do a question like this one up here. Okay? So rationalizing the denominator and numerator. Let's look at a simple one. 4 over root 3. How do you rationalize it? Well, you multiply the top and the bottom by root 3, because a root times a root gets rid of the root. It's their square root squared. Okay? And you get 4 root 3 over 3. Well, what if you have something like this? 4 over 1 plus root 3. Well, in this case, you can't multiply the top and bottom by root 3. It won't rationalize it. Okay? The meaning of rationalizing is to make an irrational, change the bottom from irrational to rational. Root 3 is an irrational number. We don't know what it is to any decimal place. We don't know the pattern of the decimal places. Can't write it as a fraction, so it's not rational. So 3 is rational. It's a rational number, so we can rationalize the denominator by making that rational that way. Here, how do we make 1 plus 3 rational? Well, we're going to multiply it by its conjugate, 1 minus 3, calling it its conjugate. Okay, where you change the sign in the middle. This becomes a difference of squares factored. So recall that x minus y times x plus y equals x squared minus y squared. No middle terms in that. Okay? So if we do that here, we're going to get the same result. So the top, multiplying it out, same. That's obvious. The bottom, when you expand it out, you get 1 minus root 3 plus root 3 minus 3. These two middle terms go away. Just as shown there, you get 1 squared minus root 3 squared, which is 3. And this becomes what you get, and it simplifies down to that. Simplifies down to that, and the numerator is now a rational number. For the numerator, so say the numerator is irrational and you want to rationalize it. Well, we do the same sort of thing. If it's just a single square root, then you multiply top and bottom by the same thing. If it's this type of thing, 2 minus root 3, well, multiply top and bottom by 2 plus root 3. You do that all out, you get 2 squared, which is 4, root 3 squared, which is 3, and you've now rationalized the numerator. This last one is the one that we're going to be looking at next. Okay? So now we're going to finish the example where f of x equals root x. At x equal to 3, we want the instantaneous rate of change. Okay, so we've got this as our formula for instantaneous rate of change. And when we sub that into the square root, we've got something that looks like this. Now, the bottom is dividing by 0. We don't want that. That's the part that we want to get rid of. So we want to rationalize the numerator, and if we do that, we're going to have something plus something on the bottom, which will help us from having to divide by 0. So by rationalizing the numerator, we multiply by root 3 plus h plus root 3. Okay, change the sign in the middle. Okay, and when you do that, it's the first one squared, so you basically get rid of the square root, and the second one squared, let's get rid of the square root with the minus in between. Okay, it's our difference of squares formula. The bottom still remains a little bit ugly. The 3 minus 3 go away, and you're left with this expression. So now you just have what? A single h on the top, and you have an h on the bottom. If you didn't multiply it in, you can then cancel it out right away. This will happen with pretty much all square root functions. Okay. Once you got rid of that h on the bottom, then you've got this nice function to take the limit of. Okay. And you can see this expression here, as h approaches 0, would definitely approach 3. So as h approaches 0, this is going to approach 3. The rest of it doesn't matter because it doesn't have an h in it. Okay? So when you take the limit out, because you've applied it, you get 1 over root 3 plus root 3. And here is the solution to that one. So the instantaneous rate of change of f of x equal to root x at x equal to 3 is 1 over 2 root 3. So that's the slope of the tangent there. Okay? Some other examples that you can try are these. So you can pause the video now and then you can try them. And then I'm going to show you the solutions to them. So it's going to come next if you haven't paused it. So here's the solution to f of x equals 1 over x squared at x equal to 2. Okay, so the instantaneous rate of change is the limit as h goes to 0 of this. Okay, now the denominator is squared, but we still have to get a common denominator. Instead of dividing by h here, I'm going to multiply by 1 over h. It's the same thing. And it just helps me keep it organized better. And by simplifying the top, we get it all worked out to this nice expression right here. And at that point, we can take the limit. It equals negative 4 over 4 times 2 squared. The 2 plus h ends up becoming 2 as the limit. Negative 4 minus h ends up becoming negative 4 as the limit. Okay, we got this, and it simplifies down to negative 1/4. Okay. The next example, which was this one here, root of x plus 3 at x equal to 2. Okay. It's right here. So the limit as h goes to 0 of 2 plus h minus f of 2 all over h, plugging in the values here for x and h into the function. Remember, it was x plus 3 here, so this is going to be 2 plus 3. Simplifies to this expression. Now you just multiply the top and bottom by the conjugate because it's a square root. 5's cancel out on the top, h's cancel out. The limit of this is quite nice. The 5 plus h goes to 5, sorry. And you've got this expression. Okay. And then the third other example is this one here. It's a combination of two functions, x squared and 1 over x at x equal to 2 again. Okay. And here's what you get for this one. Okay. F of 2 plus h minus f of 2. Plugging it all into that expression that you've got. So with the h's in it for the first part, without it for the second. Okay, instead of divided by h, I multiply by 1 over h to make it easier to look at. Okay, keep expanding and simplifying, canceling out the h's where you can. Okay, each one's separate. And then you finally get down to this expression here. And the limit as h approaches 0, well, this ends up being 4, and this ends up being 1 over 2 times 2. Okay? And you get 4 minus 1/4, which is 15 over 4.